So we got a brief holiday from the variables when we were first talking about multiplication, but now they're back with a vengeance. Again, when you're multiplying these, you're supposed to do top times top, bottom times bottom. I'm going to do it once without any reducing beforehand, and then the second time I will reduce before I dive in. So if we go straight for the multiplication, you do this in passes where you do the numbers followed by the variables in alphabetical order one at a time. So when I do this, it goes like 12 times 3 is 36. I'm ignoring everything except the numbers. Now, x times x makes x squared. Ignore everything except the x's. Now ignore everything except the y's. We have y times, there aren't any others, so we just keep our single y. And then we have z squared, and there aren't any others. And in the denominator, we have the number 4, no x's, a single y, and a z. So I'm pushing this into alphabetical order just to make things easier for myself. Now, if we reduce this, you see 36 divided by 4. We can actually do that. 36 divided by 4 is 9. We have x squared. Now, we have y divided by y. Those cancel. That leaves us with y to the 0th power, which means no y's at all. And then we have z squared divided by z. That means we can cancel the z in the denominator. We can cancel one of the z's in the numerator, and a single z remains. So 9x squared z would be our finished answer. If you reduce this beforehand, which is often a good idea, I'm not going to say you must, but you may find it helpful. You can do things like this. Here we have 12 over 4, so we can say 12 divided by 4 leaves 3, 4 divided by 4 leaves 1, and then switch colors. We have y divided by y leaves 1, and y divided by y leaves 1. And last thing we can do, here we have z squared over z, so z divided by z leaves 1, and z squared divided by z leaves simply z. So we've got all our reductions done. After that, if you multiply this out, let's see how this turns out. We have 3, sorry, I don't like the order I was doing that in. Let me try this again. Numbers, we have 3 times 3 makes 9. We have x, and another x is x squared. We have z, and in the denominator, well, there's nothing left. We could put this whole thing over 1, but there's not much point to that. So we get 9x squared z anyway. Again, I apologize for the clutter in these. It's a lot of information to cram into that little space, and you'll find if you do these even pencil and paper that it's hard to keep it all readable. Just take your time, and if it's getting too messed up, recopy it before you keep going. Let's see what happens with this one. Okay, I'm going to try to do this, just multiply and then reduce. I think I'm going to regret it because the numbers are so big and this thing is so complex. Here I think the reduce before version is going to shine, but I'll do it the clumsy way first. 5 times 35 is 175. A's, I have a squared, and there aren't any others. B's, I have b squared times another b makes b cubed. C's, I have c to the 4th over, now downstairs, 14 times 40 is 560. A cubed, b squared, and there aren't any other b's. C times c makes c squared, and d, there are no other d's, so there we are. Now, here's where I pay for doing it this way. Are these reducible? I believe, well, I know 175 has a 35 in it because that's how we made it in the first place. I think 560 is divisible by 35. I'm just going to check that on the calculator. Yes. 35 goes into this 16 times, so let's reduce that and see what happens. 175 divided by 35 leaves 5. 560 divided by 35 leaves 16. 5/16 can't be reduced any further, so that's the end of that story. Here we have a squared versus a cubed. If I divide both of these by a squared, here's what happens. I get a squared divided by a squared, just leaves 1. A cubed divided by a squared just leaves a. With the b's, same thing. Divide by b squared, the smaller number of b's. B squared divided by b squared just leaves 1. B cubed divided by b squared leaves simply b. C's, same deal. I can take out 2 c's, so the c squared cancels, and the c to the 4th gets cut down to c squared. And I have nothing to cancel the d against, so we're stuck with that. So, in the end, we have in the numerator 5. The a's are toast. We have a b left, and we have c squared. In the denominator, we have 16. We have a, and we have d. I'm leaving out the 1s because multiplying by 1 doesn't change anything. It's almost always pointless to write these. So, finished result, 5bc squared over 16ad. Now, that's our finished version there. Now, if you don't see this 35 thing here, it could have been quite a grind reducing this. Saying, okay, I guess it's divisible by 5 because these numbers end in 5 and 0, and then you may have found the 7 after that, but generally it's kind of a miserable exercise working with big numbers like this and trying to reduce them, and then worrying about whether you've really reduced them as far as you can. Here we got down to 5/16, and so it was fairly clear that this couldn't reduce anymore, but in general, you're going to hurt if you have to reduce a big expression like that. So here's the other way, reducing before. Let's see, 5 and 40 are both divisible by 5, so we'll do that right away. 5 divided by 5 is 1. 40 divided by 5 is 8. Here's another one. 35 and 14 are both divisible by 7. 35 divided by 7 leaves 5. 14 divided by 7 leaves 2. That green's a little light. I'm going to go to something darker. A squared and a cubed, we can reduce those beforehand as well. We can say I'm going to cancel 2 a's in the numerator and 2 a's in the denominator. There's 1 left over. B's, I've got b squared and b squared. I can cancel those. C's, now this is awkward because the c's are all over the place, but we can still do this. It's going to take even more scribbling than usual. C to the 4th versus c. I can cancel this c, and I can cancel one of the c's upstairs, so now I have 3 left. Then I can cancel this c in the denominator, and we lose yet another c upstairs. Now we're down to c to the 2. Even with color coding and my best efforts to keep this neat, it's starting to look pretty awful. But I think that's all of the reductions that we can do. Now let's see if I can read my own writing well enough to reconstruct this. In the numerator, we have 1 times 5. There are no a's. There's a single b. And here we have c squared. This is a 3 that got scratched out, and this 2 is the real exponent. C to the 2. Downstairs, we have 2 times 8. We have a single a. There are no b's. There are no c's anymore. They've been scratched out. And we have a single d. So, problems like this are kind of a pick your poison. You can either have big numbers to tangle with, or you can have an expression that's a bit of a mess. It's up to you to decide which one of those bothers you more.